I'm okay, and you?
I'm very good, very good. It's sunny day
Okay.
here in Minnesota, northern.
Oh, all right. All right. I was having a little problem here,
Yeah,
trying to connect because of network. The network here is a bit poor.
sure. But it's coming through great right now.
Okay. So how is the weather there?
Hi, I'm Luther Kruger with the Big Blue
Okay.
Sun Museum of Solar Cooking based in Minneapolis, Minnesota, North America. And I'm here with Wilfred Okonkwo, who is a professor of in the Department of Agricultural and Bioresources Engineering in University of Nigeria in Nsukka, Nigeria. That's in Southeast Nigeria. I connected with Wilfred because I ran across an article that he wrote about solar brooding. And I, even though I grew up in rural areas of the United States, I had never heard. I've heard the term brooding, but I had never heard of solar brooding before, and so that struck my curiosity, and I wanted to hear what that is all about. Why were you researching that? What are the results, and where does that stand? And then also following up with after that, you have a book, if I understand correctly, on solar cookers using reinforced plastic. If that's good, we can talk about that too. So yeah, let's start with solar brooding. What is that, and what is your research showing you?
Okay. Thank you very much. I'm very happy for you locating me from the work I've been doing for some time now. Actually, I'm a lecturer at the University of Nigeria, Nsukka, and a professor, just as rightly said, at Department of Agriculture and Bioresources Engineering. Also, I've worked in National Center for Energy Research and Development in University of Nigeria, Nsukka for years, before now getting to Agricultural Engineering Department. Let me go straight to the point. Solar energy application in poultry production. In other words, solar energy application in agricultural activities, processing activities. Here we have done extensively research into the utilization of solar energy in poultry production. Poultry production, as we know, are of stages. You have incubation stages. That's incubation of the egg, where the egg hatches into chicks. After chicks, you have brooding. After that, you have rearing. Either you rear for table meat or you produce for egg production. So in solar energy application in poultry production, we have done, using solar energy for poultry brooding. Brooding technology is a kind of supply of heat to the old chicks. After the hatching of the eggs, the next stage of the chick is to provide them a warm place, an environment that is conducive, so that the chicks will not die of cold. If you leave them in the ambient temperature, in the environmental temperature, they will die of cold. Naturally, the mother hen, after the hatching of the eggs, you see the mother hen using the wings to cover the day old chicks, that the small chicks, so that they will not be, the environmental effect will not affect them. Environmental, surroundings will not affect them more, especially the heat. The essence of using the feather to cover them is to provide them the needed warmth they need so that they will not die of cold. That is traditional method of brooding. In that case, that is the natural method. We found out using the natural method, it works, but for commercial purposes, it doesn't work. In our environment, Nigeria here, what we do here, the poultry farmers do, either they use collection of electric bulb in an enclosure. that in a room to provide the needed warmth, or they use kerosene stove or lantern in that enclosure to raise the temperature of the room or the environment to about 35 degrees centigrade, so that the chicks will be comfortable within the ticks. But we found out the poultry farmer, they are spending a lot of money. It's expensive to use fossil fuel. That's kerosene. In our environment, in our system now, a liter of kerosene in Nigeria is almost $1. And that is about 400 naira per liter, which is very costly for people that are into poultry production. We talk of electricity. Yes, electricity is a clean energy. But in our system or situation here, we found that electricity, because of the outages, the power failure, and in most of the rural areas, there is no national grid. So the farmers in the rural area and the semi-rural area, they beckon on the use of fossil fuel. We know the problem of fossil fuel. The problem is expensive, environmental pollution, carbon monoxide and carbon dioxide emission into the environment, contributing to global warming and climate change. What we have done over the years, we have done now trying to find a means. How do we help the farmers in our system, in our locality or tropical country location? In Nigeria, we have abundant solar radiation supply because the heat from the sun is always there. And this heat can be harnessed for useful purposes. And one of the area we now channel it is to use it in solar application. What we have done is to harness the solar heat for purposeful use in brooding solar poultry production. We have developed different versions of solar brooding systems. We have worked on the small scale system for people that are doing it maybe at their backyard of a capacity of 50 chicks per brooding section. We have also gone ahead, after that one worked, we have gone ahead to develop another medium scale system where you can brood up to 150, 200 chicks. And that one worked. Now we say, now if one is going to commercial poultry production, this medium scale, small scale system might not be good for starch to make maximum profit. We developed another system we call Trombe wall system. That Trombe wall system is now, Trombe wall system is a special wall that is meant for solar energy collection, storage, and dissemination. So we have used it and it worked. We have also used it for our environment here. Some poultry farmers are having it now to use it to brood their chicks, even the middle scale system. Years past, at a point, I got a grant for UNESCO for commercial trial of the medium scale system, which we did and gave to some farmers. And they use it and it's working. After that, we went to the large scale system. So what we have done, we have provided farmers a system that is sustainable. The energy cost is low. What you have to do is once you get this system, you have it in your farm. About the cost of energy is you don't have to think of electric bill. You don't have to think of the money you are going to spend to get the fuel for a kerosene or whatever, or gas system. Once you have it there, the sun comes there every day. The sun is a renewable energy. The sun in the system collects the energy, stores it, disseminates, and conditions the environment where the chick stays. So this is the work we have done over the years. And if you look around, you find out I've written extensively some of my works on this solar brooding aspect. We have done it in our environment. Right now, we are also trying to get it across the government or people that are interested so that this thing, farmers can have it. You know, in our system here, farmers, what we have, we don't have all that rich farmers. We have the farmers that are mainly coming up. What they need is incentive, help to get this thing across to them. About the system is environmentally clean. It mitigates climate change. So this is in a brief what we have done in this aspect. Also, we have also gone some aspects, also developing solar incubator, solar egg incubator. This solar egg incubator is powered by solar energy. So what we are trying to do is where you have a system that is solar, that's renewable energy dependent. You don't need to augment it with external energy, electricity, or kerosene. So this system, you can locate it in any remote location, in local areas, in the communities, even in the urban centers. And then again, you don't need to worry about your energy. So that you have your incubator, you can have your incubator. Once your eggs is hatched, you transfer them to the solar brooder. The solar brooder, after brooding it, you can now take them to your rearing house. Moreover, we also developed another system we call solar manure dryer, poultry manure. You know, the poultry manure is liquid in nature. It contains moisture, it contains water. So for you to transport it, handle it, and store it, you need to do a sort of drying. So we also developed a system that can dry the poultry droppings, and then you can bag it. After bagging it, it has many applications for farmers, for soil conditioning, people that are, crop production, even people that are doing animal rearing in fish pond, in piggery. They also use it as a supplement in order to other feeds. The system of solar design is summary of what we have done. There are two aspects of solar designs one can think of. You talk of active system. You talk of what? Passive system. More especially, our system is passive. We also incorporate, our system is passive. We also have active systems. Active systems are in a case where you have the solar aspect part, you have some other augmentation. Maybe if the solar is failing, the electricity will come up, or gas, or whatever addition. In other words, it can be hybrid. But in our passive system, we depend solely on solar, on natural application. In the control of the environmental elements, that is where the design comes. You design your system based on the capacity and based on the environmental factors. The temperature should be there, the relative humidity should be there, and also you should know the amount of solar radiation in your environment. And also the sizing of your system. You should be able to have a system that can store the amount of energy you need in your system. And also you can also give a kind of allowance, prevention of time of off sunshine hours, cloudy hours for prolonged sun time, so that your system will be able to hold the capacity, the storage can be able to hold your system. In that design of passive system, you beckon on natural control. That is where you will now look at each aspect, each unit. What is the size of ventilation? What is this and this? And then you look at it, the operation, the amount of heat, energy coming from the solar system. And also as a living thing, they also have what? The metabolic heat of production, which they give out. You also have to incorporate this into your system. By the time you sum this, it will give you the heat load of your system. And then you design based on the capacity and also the environmental needs. So by that, you use environmental, whatever the environmental factors to control your system. If it is active, you can now incorporate some other systems, thermostat, that can be able to control the temperature up and down when it goes up and down. But as passive, if you incorporate thermostat, you have to bring in electricity to control it. In that case, it is no more a passive system. But in the passive system, you use natural factors to control your system. Right.
Question. I know of people who have greenhouses where they raise plants, sometimes vegetables, but often flowers, and they need to keep it from getting too hot. Usually, that's the great thing about solar energy, is it's almost an infinite capacity, and I've seen these valves that are like a piston that is filled with a kind of a wax or some kind of fluid that will expand to open a vent if it gets beyond a certain temperature. Is that something people could use to control the temperature?
Yeah, in greenhouses, you should just have to be ventilation to control the temperature. If the temperature gets high, the vent you have can have to be closed or minimized. If the temperature is getting higher, what you do, you have to open the vent so that there will be what? There will be free, the air can flow out, and then there have to be what? A kind of heat transfer between outside environment and the inside. Either the heat flow from outside or the reverse. Likewise, in the passive system of solar system, this is the method, that's what I say, that you have to use environmental, the natural system to control it. You have to have vent where they have even the chicks themselves, they also respect. They give out carbon dioxide. Of course, if you leave it in a house, it will build up. There has to be a place, a way where the carbon dioxide and monoxide will get out of the house, and the environment to keep what? Environmentally clean and conducive for the chicks to produce. Yes.
The passive systems, that's a fairly relatively easy system to set up, and people can set it up on a certain scale, maybe modular. Maybe they have they find the system that works for so many chicks, and they could just make another one and another one the same size. Or do you find that people expand using formulas or research that you provided?
What we do is that it's based on the system. If you want a small scale system, the size of the number of chicks you want to do determines the size of your brooder. You got it?
Sure.
And this size now, if it is small system, there are different methods or systems you use to store the energy or materials. Let me say materials. Is either you use water. Water is a good storage. You can use to store the heat. You can also use pebbles to store the heat. You can also use wall, special wall we call Trombe system to store it. You can use salt, but in our environment, you will mostly use water and the Trombe wall system to store the energy for the heat aspect of the brooding.
The Trombe wall, is that like a tank of water that runs up the wall, or is it wet material in some storage, or what is that?
Trombe wall is a special wall. It's just a special wall that is just my building materials. It's just conventional building materials which you have to design based on the solar design principles. You got it? It's just Trombe wall can be it's a massive concrete structure, solid block, but now you have to treat it. You have to put it in a particular orientation so that it will collect the solar energy from east to west. As the sun rises from the morning from east, it will collect it throughout the day and it goes down. The one that is collected during the day stored is one that what we'll be using within the environment during when the sun is not around, out, And as it is using it, by the time the day breaks, it continue collecting the heat and stores it and continue to disseminate into the environment. So we use it's a special wall. No, it's not different from the conventional wall. But what is different is that you have to design it based on solar principles. You have this wall has to be black to become an absorber, a solar collector. In other words, it becomes a flat plate solar collector. Likewise, the small scale system is a tank structure. Water in a water tank, which you have to design to be able to collect some water and stores it and disseminate the water into the environment.
That makes sense. I really was not familiar with that before I saw your paper on that. So that's great to know. Well, if we may, I'd like to talk about your book, if that's correct, the Reinforced Fiber Plastic Solar Energy Cooker. Is that your book? And what was the origin of that? I actually ordered it so I could get a copy. So when I edit this episode, I can talk more intelligently about it. What inspired you to write that book? What's the story?
The reinforced fiber reinforced concentrating solar cooker is a work that we have done here. Most of the works we saw before that time, they were done either parabolic solar cooker or box system. In the box system, you just have a box, make the inside black, and then try to harness solar energy and have a kind of a greenhouse effect, where the temperature will build up and then you start cooking whatever you're cooking. But in the fiber reinforced concentrating solar collector is a system, because we found out that what people have, they have a kind of a curvature concentrator that now receives solar energy from the sun, incident energy and reflected, which comes to a focal point where you now put your pot. But we use fiber reinforced is a material that we also located locally here. We now, have to use it. We use it in many areas, in motor, cars and all the other areas. So, but this one, what we said, let us use it because it is cheaper than the other ones where you have a curvature. You have mirror, pieces of mirror start to stick it. By the time there are some defects, some strand and lines that also affect your system that can make your collection be blurred. But in this one, this fiber reinforced, we developed the material here. We use it to mold. We have a mold where you can now mold, have a kind of a template. You put it there. When you form the fiber resin, you put it there, leave it for some days, and it's now hardened, and you bring it out. What you need to do is just to put a reflecting surface inside that can reflect the incident ray at a focal point where you put your cooking pot.
What size generally do you make the parabola? A meter, 2 meters? What size?
The size depends, if you make a small size, the bigger the size and the smaller the focal point, the better. You get it? It can make small size, but that small size might not be as efficient as big size. But you don't have to make a very large one. Remember that it has to be outside for it to work.
Sure.
The moment you make the one that's sizable, like the one we have, I will show you, you get it. I will show it to you. If I send it to the one we have sent, you must have seen it in my papers, a book I wrote with one of my students. I don't know whether you saw the book, fiber reinforced, a book called Solar Cooking System. So that's the thing. The size you want. You can design for a system that can cook for some people, maybe 3 persons. that can hold pot, big pot, small pot, that can determine the size of your cooker. If I'm designing for 2 persons, it will be different from the one I'm designing for 3 or 4 persons. That of 4 persons will be bigger, because it will need bigger pot for you to be able to cook a batch of food for the number of people you want to feed.
And you chose, it's economical, it's easier to make, and it's lighter weight than, say, metal or any other substance where you put mirrors on it.
Yes, we choose it because it's easily malleable. You can twist it, you can form it any form. Once you do it, it becomes a liquid, a solid liquid. What you have to do, once you form it to a formula, you put it in that mold, because you have to have a mold. In that mold, you now cast it on it. After 2 or 3 days, you go and bring it out. That becomes your mold. If you want to do 100 many in mass, you can now use it to produce as many cookers you want.
And how common, how many people are using these cookers? Is it fairly common in Nigeria, or are you finding challenges to promote solar cooking in Nigeria?
Right now, all we have done, we have trained some people, but the issue of using it is what I can say that this is the number of people that are using it now. All right. Mm-hmm. Because in Nigeria, people, there are many options. Most people in the rural area, they prefer using wood, and that is affecting our forests right now. Deforestation. Sure. It causes deforestation, brings about erosion. It brings about desertification. But the issue of using it, the promotion, that is the aspect that we are also looking at. If we can get people that we can collaborate and work with, we can pass it across to people, mostly in the rural areas. The sun is there, and if they are using it, it will save them a lot of money. The time going to bush to fetch the wood, it saves them time, and also save them the money they use in buying the wood and the energy. So like right now, like myself, we are in the university. And you know what is it in the university in Nigeria, in the third world country? The issue of research. Many researches have been done, but passing it across to the end users, because there is a gap between the end users and the research that is produced here. These things are produced and they are there lying down. Most of the things we do here, what we do is that once in a while we organize seminar, workshop, we organize conferences, people will come, we talk. After talking it, people will go. Unless you have a kind of sponsorship that can now ginger you to reach out to the end users, bring them, at the end of the day, give it to them. Just like the one I told you, the brooding system. When I developed that one in 2000, I got a grant from UNESCO. When they saw the work, I made a proposal, and they gave me a grant for commercial trial of solar small scale, medium scale brooding system, which we did. We did some version of that system and gave it to farmers. And farmers will also follow them, monitor it, gather information, and they report their comment, and we had it. That was what prompted us to go further for the large scale system. So in this area of how many persons are using it in Nigeria, that question is really, I cannot answer it. No person, I can't tell you, because we have not really done the dissemination workshop or getting it across to the end users. Sure. That area is lacking.
Are you familiar with Solar Cookers International? They have a map online where people can register saying, hey, we have distributed so many cookers here, in Asia countries or in Europe or I actually collect cookers. So I have a dot on the map that represents the 80 cookers I collect. And it might be worthwhile to, if you have any follow-up that can be done with students, to see if there, how many of them might be out there. And I can send you the link if you want to record that. It's helpful for people to see that and realize, you know, they are all over the world. It's not easy to find out how many. I know this from being involved for several years now in solar cooking, but it's worth knowing that it is out there and that people are doing the research. Can I post your email on this video and people can email you with questions if they have them?
I would like to associate myself with them, but I'm not a member right now because maybe I don't know the organization. I think I've come across on my passing across, you know, some of the literatures, but I've not really contacted them. I would like to be, because this is the research work we have done, and the which we need it to get across to people, more especially the end users, women, cookers, and the restaurants, you know. Yes.
I'll send you all that information. You can find it, of course, Solar Cookers International, and then they have a wiki which stores all sorts of articles on solar cooking. And sure. And I can't think of any other questions. Do you have any questions or further comments that you'd like to share? Or any questions for me?
Well, the question I have for you is, first of all, I just have said, I'll thank you for picking interest in my research work. And that is one. Secondly, is that I would like to work with somebody like you, because I am somebody that like discovering things and getting across people, let people know what is happening in my domain. Yes, if we can work together, I assure you that there are many things we can do. Solar cooker, solar desalination, I work in solar desalination system, solar brooding, solar application, solar crop drying. These are the areas, solar thermal applications. So any of this area we can work. Even we can also produce, if we want, we can produce, even if it's book, can put our hands together and do some joint write-up and get it across to people, because people need this thing in the rural area, in the town, in many places. But the thing is that, how do we get it across to them? So I want to thank you very much. Yeah, video, I wanted to open it that to YouTube, but I will find time to look at it critically and watch it. I know it's a quite interesting one, and I'm happy that I've known you today and you have known me. Yes.
Well, thank you so much too. I appreciate taking the time. It's sometimes scheduling these is a real challenge, but I really appreciate that you got back to me instantly. That was great. So thanks again. And if I have any more questions where we might need to connect, maybe we'll do another Zoom. But I think we covered everything here. This is fantastic. So thanks again.
Thank you very much.